Hello, all. My name is Krish Nayak, and welcome to my YouTube channel. So, guys, I am super excited to start this new series on one of the most important technique, which is right now being used in generative AI and agentic AI field. That is nothing but RAG. If you don't know the full form of RAG, it is called as Retrieval-Augmented Generation. In this specific video, we will try to understand what exactly is RAG, what are the disadvantages of just using the LLM model and how we are overcoming those disadvantages with the help of RAG. When should we use RAG? And what are the important pipelines that we should take a note while developing a RAG application? Okay. So all these topics we will be discussing. And as we go ahead, we are going to implement each and every important pipelines with the help of Jupyter Notebook. And I will also show you with the help of modular coding, right? So both the ways we will try to implement it. Now, why I'm stressing on this specific series? Because nowadays every companies are looking for professionals who knows how to build RAG applications, because if you see various AI engineering reports, there many of the companies, around 60 to 70 projects percentage of the projects are specifically on RAG application. So let me quickly go ahead and share my screen and start discussing about RAG. This is just the introduction video of RAG. And as we go ahead, we'll be implementing more amazing examples. So let me quickly go ahead and show you. So this is a simple definition that I've put up over here. And in this definition, first of all, we'll try to understand RAG. Okay. So first of all, let's go through the definition and then I will give you a brief idea what exactly RAG is all about. So here you can clearly see that RAG is the process of optimizing the output of a large language model. Okay. So it references an authoritative knowledge base outside of its training data set source before get generating a response. LLMs are trained on vast volume of data, as we all know, and use billions of parameters to generally original output for tasks like question answering, translating, and completing sentences. RAG extends the already powerful capabilities of LLM to specific domain or an organizational internal knowledge base, all without the need to retrain the model. Okay. It is cost-effective approach to improve LLM output, so it's relevant, accurate, and useful in various contexts. So this is just a basic definition. You can refer to this particular definition. So guys, now let's go ahead and understand about RAG. So let's consider that I have a generative AI application. And as you all know, in a generative AI application, usually, let's say that I have an LLM. So this is my LLM. Now, usually whenever we have a LLM, what happens is that let's consider that I have a user. A user is asking a query. So this is my query from the user. And before it is sent to the LLM, we do add a prompt, right? We do add a prompt. And this prompt is just like an instruction to the LLM, like how the LLM should work. Okay. And then based on this, we actually get an output. Now, this is a simple generative AI application wherein the LLM is used to generate the content. Okay. Generate the content. So obviously by using this specific technique, we give a query and this LLM, you know that it is being trained with billions of data. Okay. Different kind of data that is available in the internet. And based on this, it will be able to generate the output. One of the disadvantage of this, let me talk about the disadvantage of this particular approach. As you know that every LLM that is trained, it will be trained for a specific set of data. So let's say right now it is 31st August. Okay, 31st August. Let's say this is my LLM model and this is basically GPT-5, which is the recent model from OpenAI. Now, as you know that when this model was launched, this model may be trained with data till 1st August. Okay. So this LLM will not have any idea what has basically happened in the current world between 1st to 31st August, right? And let's say if I go ahead and ask a specific question to the LLM, which is between these specific dates for any kind of events, the LLM will start hallucinating. So one of the major disadvantages of only using the LLM is that it will hallucinate. Okay. When we say hallucinating, what does this basically mean? It means that even though it does not have the knowledge what has happened between 1st August to 31st August, any events, even though we ask any question, the LLM will try to generate its own answer because it does not want to look like a fool. Okay, that is the best example. It does not want to look like a fool, so it will try to generate some answers and it will make sure that it will it will show you an answer that you may also have to believe it. That is how it will be written, in terms of the output that we get. So usually this condition is basically called as hallucinating. Okay, so this is one of the major disadvantage. The second disadvantage that you have, so let's say that I'm using this LLM, and this LLM has been trained with huge amount of data. Now what happens is that I'm running a startup, let's say. Now in my startup, I'm solving a specific use case and I have some data, which again, I need to use this particular data along with my LLM. Okay. So let's say that I have some of the data like, you know, policies, policies of my company. I have HR policies of my company. I have finance policies, and these policies all will not be available it will not be available publicly because it is my startup. So this all data has been protected. Now I also want to use this specific data and probably create a chatbot. Okay. Now, how do I do this? Now, one way is that many people will say, hey, Krish, we can take this particular data and we can fine tune the model, right? We can simply fine tune the model. Yes, this is a very good solution. But understand, fine tuning a model is a very expensive process, very tedious process because this LLM, whichever LLM we are using, it has billions of parameters. And tweaking this billions of parameters usually takes a lot of time, right? So obviously, this is a solution, but this is a very expensive solution. Okay. Now, do we have any other way? Any other way? And remember, these all policies and these all data will also keep on getting updated as we run the startup, right? So every time we cannot just go ahead and fine tune it. Like every day we will not fine tune it, right? So we should try to find out a solution. Like how do we prevent this? So this can again be prevented with the help of RAG, right? Now, how it will be prevented with the help of RAG, I will talk about it. Okay. So here, instead of fine tuning, I'm saying that, hey, I will go ahead and implement the RAG. Now, you'll understand only when we understand the pipeline of the RAG, which I will discuss in this specific video. Okay. Now, these are the major two disadvantages that you see right over here. And yes, there are some more disadvantages, which we'll just deep dive more as we go ahead. Okay. Now, what happens in if we use RAG and how we are preventing it? See, RAG is nothing but it is saying that it's a process of optimizing the output of a large language model, so it references an authoritative knowledge base outside of its training data. Now, how do we solve this hallucinating and this problem that we have? Okay. So let me just go ahead and draw the diagram again. Okay. So here is my LLM. Okay. And here is my query. So let's say that I am coming up with a user query. So let's consider it over here. Okay. And here I'm drawing a user. I'm a user. Okay. And this user will first of all give a query. Okay. Now what happens is that there will be two important pipelines that will be created. As I said over here, we are trying to optimize the output of a large language model so it references an authoritative knowledge base outside of its training data source. So as you all know, this is my LLM, right? This LLM is already trained with huge amount of data. Now along with this, I will be having an external database. And this database, we basically say it as vector database. Okay, external vector database. Now you know that this LLM is already trained with some amount of data, and any additional data, let's say my startup data, my policies, HR, finance, whatever data is there, we will try to create a data ingestion pipeline over here. Data ingestion pipeline over here. Now, what will be this data ingestion pipeline? So let's say I have my data. From this data, we will do some kind of parsing. And from this parsing, we will do embeddings. And then we finally store it into the vector store. Okay. Now, whenever we talk about this specific data, this data can be in any format. It can be in PDF format. It can be in HTML format. It can be in Excel format. It can be even in SQL database format, or unstructured format, any format. So what we do, initially we take this data and we do data parsing. Now here, data parsing is a very important step. I think if you crack this step, then developing a RAG application becomes very easy. Data parsing is all about how do you read the unstructured data or the structured data that is present inside this, and how do you chunk this data, right? How do you chunk? How do you divide this specific data into chunks? Chunking is very important because you need to save this data inside some kind of vector store. This is nothing but vector store or vector DB. Okay. Now, vector store and vector DB is nothing but it will actually help you to save vectors inside this. Okay. So once you do the chunking, after doing the chunking, you pass it to the embedding models. Now, here in the embedding models, you basically convert text to vectors. Okay. Vectors is just like a numerical representation for text so that you will be able to apply algorithms like similarity search, cosine similarity techniques that are already available, right? Wherein similar kind of results based on a specific query can be retrieved from this particular databases. Okay. So here, whenever I talk about vector DB, this is my vector DB or vector store. Here we are storing embeddings. Okay. And these embeddings will get applied to every chunks. Embeddings is nothing but we basically we convert text into vectors. Here we can use different embeddings like Google Gemini embedding models. We can use OpenAI embedding models. We can use Hugging Face embedding models. And each and every embedding models exist with different cost, and there are also open source embedding models which will actually help you to convert the text into vectors. Now, this is one specific pipeline which we call it as data ingestion pipeline. At the end of the data ingestion pipeline, you are able to store the text into vectors inside your vector DB. Now, how RAG is different from the previous one, right? So initially you had this data ingestion pipeline where you are converting all your data into vectors, right? And this data is specifically for this particular startup. And now I have created a knowledge base. So this is my knowledge base. External knowledge base or internal knowledge base, whatever knowledge base I have. And this knowledge base does not exist with this LLM, right? Yes, some amount of information may be available, but not the entire part. Now, see the definition. It is a process of optimizing the output of a large language so that it references an authoritative knowledge base outside of this training data. Now, what will happen? When user gives a query, now this query, instead of directly going to the LLM, will go to this vector database, right? And before going, here also we need to go ahead and apply embedding, right? Because this query will be converted into vectors, right? Why we need to convert into vectors? So that when we are hitting this query to the vector DB, this similarity search is basically applied. And based on this, we get some kind of context. We get some information from the vector DB. And now whatever query I'm asking, okay, if I ask, hey, what is the leave policy of my company, right? Now what will happen? First of all, it will go to the vector store. It will gather all the related information that is available over here. And that information, when it is sending it to the LLM, it is called as context. Now we use this context along with, we go ahead and write a specific prompt. Now this prompt is an instruction to the LLM, and it says that you can use this context to answer the question, and finally you get a output. This is the entire pipeline. This pipeline is basically called as retrieval pipeline. Retrieval pipeline. And this is a very good example of a traditional RAG. Now you may be thinking, Krish, what about other types of RAG? Don't worry. Don't worry. I will explain it completely from basic to advanced with implementation, each and everything. Because later on, we'll be discussing about agentic RAGs. We'll be discussing how agentic RAGs actually work, each and everything. But I hope you got an idea with respect to this. Now, here, you will even not be seeing this particular problem. Like, you'll not completely remove hallucination, but some amount of hallucination. If any queries that is asked related to the data that is present in the vector DB, I will definitely get some kind of context, and my LLM will give me the output. Yes. Let's say that if that data is not present over here, then LLM can hallucinate, right? But here we are doing this. See, one best example that you can do is that you can use perplexity. Perplexity is nothing but it is based on RAG. It is completely developed based on RAG applications. Okay, RAG. It is a kind of a RAG application. In Perplexity, you have connected to various retrievers. You are connected to tools. You are connected to web search, right? And then it is summarizing the output and giving by the LLM, right? And it also uses various LLMs itself. I'm also planning to mostly start a startup soon enough, within a couple of weeks, I guess. And the kind of application that I'm developing is a RAG application only. And it solves a very good problem for a developer. Okay. So that is the reason I'm not being able to upload a lot of videos, because I'm pretty much involved in those startups and working and developing a product that India can definitely remember. Okay. And this is how, this is how things are, and you can basically see how good uh, you know the pipeline actually works. And this is basically a traditional RAG. Now you may be thinking, Krish, what all things we'll be discussing? Okay, fine, we have discussed about a traditional RAG. In the future classes, what coding we'll be doing? Okay, so let's go ahead and talk about it. As I said, two important pipelines we'll go ahead and create. One is a data ingestion pipeline and one is a retrieval pipeline. Okay, now in the data ingestion pipeline, you'll be seeing that we will be performing data ingestion. Along with the data ingestion, we will go ahead and do data parsing, then we'll perform embeddings, then we will store everything into the vector store, then we will create a retriever for this, and whenever a user asks any queries, it will be able to give the context to the LLM, and then finally we will be generating the output. So here, this is retrieval, this is augmentation, right? This is augmentation over here. Augmentation basically means what? You're giving a context to the LLM along with the prompt to generate the output, right? So this is basically called as augmentation, and finally you're generating the output, right? Which is nothing but generation. So here you're basically generating. Now, in the next session, how we are going to implement it. First of all, I will show you how to perform these two steps in a very efficient way. Okay, sorry, not these two steps. I will show you how we can perform these all steps, right? Data ingestion, data parsing, and embedding. Here we are going to consider different files like PDF, HTML. Okay, PDF, HTML. You can consider Excel. You can consider SQL database. You can consider any kind of files. Then we'll do document parsing, and we will try to convert this into document. So document is an amazing data structure which you can basically use it, and you can even parse this, do the chunking, and store it in the vector embedding, sorry, vector store. Then we'll perform embeddings. Here we will use both open source, and we are going to use paid embeddings for the same. Okay, and then finally we go to the vector store. Then based on a user query, how do we go ahead and apply the same embeddings? We are going to see that. Okay, and then finally we will be developing this. So mostly I really I'm focusing more on making bigger videos so that you don't just follow a playlist. Okay, I want to basically cover a lot of stuff in one video, so that you should also be able to efficiently cover it instead of covering 50 different videos, right? Now, when we are doing data ingestion and data parsing, right, there are various techniques. See, we are going to see about optimization, We are going to see about various chunking strategies, context engineering. These all kind of topics will be coming up. When we talk about data parsing, what is semantic chunker? How do we go ahead and do the chunking in those strategies and all? Everything we'll try to discuss as we go ahead. But I hope you got a very super cool idea about what exactly is RAG. Yeah, this was it from my side. Please make sure to like the video, share with all your friends, and soon within a couple of days we'll come up with the next video wherein we will be starting the coding tutorial and we'll start building this data ingestion pipeline. And I will try to build it in the form of a project that it will be looking good for you so that you'll also be able to completely implement things, right? So yes, this was it from my side. I'll see you in the next video. Thank you. Take care.